Here we go. All right, so first thing is get your digital multimeter out and plug in the leads into these holes here. So you'll have the black going into COM and the red going into the middle one, the middle section, the V ohms. So we'll start with that. You will also need to open that little white box that has the breadboard and this guy here, this little thing on top. I'm gonna need this guy. We also need the resistor kit. Let's see if I can zoom out a bit. Okay. Any resistor kit you're gonna need to pull out. So we're gonna do that question we were looking at. Here, let me pull it up again. Last time, kind of went a little fast through it, but I'm gonna give you a lot of time to work on this. So we're gonna build this circuit in real life, and then we're gonna measure the resistance of each resistor, then the current, and then the voltage. So in that Excel you made last time, you're gonna put in the measured values, okay? So I'm gonna go ahead and send this to you as well. While you find all your stuff. Okay. Let's see, this is what I have to. All right, so I'll just go ahead and send that to you. You also need the breadboard, which is this guy here. Remove all these resistors I was playing with earlier. You're gonna need the, so if you look at that Word document, there was 3 main resistors. Let's see, open that file again. Okay, yeah, so there was a 270, a 220, and a 150. So we gotta find inside of the resistor kit those 3 values. So it should look like this in there. Make sure it doesn't have a K on it, because that'd be to the thousands, and we're not dealing with that level of resistance. So we should just say 150R, not 150K. Same thing with this guy here. It's gonna be 270R, 220. So just rip one out, and then we'll go from there. Okay. Hopefully I didn't break mine. These are look like cheap garbage from China, so I don't know.
What was the which ones do we need again?
Yeah, I'll share the Word document so you don't forget. you need these guys here. So we're building this circuit.
Okay.
So I'm going to help you with the first circuit, and I'm going to have you do 2 and 3 on your own. And I'll send you some more videos on circuit stuff. I haven't sent it yet. I'm meaning to. So when you find the breadboard and the little power source here, just orient it this way with the red on the left side and blue on this side. Okay. So the numbers going downward. There's a crap ton of resistors in there, so I'll wait a bit so you can find the specific 3. And we're not going to go too deep into circuits. I mean, the idea is just really to make a fun lab that we can practice Excel on. The goal here is to learn more about Excel, but I figured why not play with some basic circuits.
I found 220R, 150R, and 270R. That's what we're looking for, right?
Yes, that's what we're looking for. I'll go ahead and type it in the chat box too. So find in the resistor kit, find 220R, 270R, and I believe it was 150. Has anyone not found them yet?
Can we use 220KR or does it have to be 220R?
It has to be no K, because that means 220 times 1,000.
Okay.
So don't use that one. They should have both in there. They're just hard to find. Okay then. So if your multimeter is connected, so I want you to switch it on to, oh, actually, before we do anything, there's these jumpers right here. You zoom in. See how it's on, it might be on 3.3 volts. You need to move them over. So pull off this yellow thing and put them on the 5 volts for both sides here. Okay, so make sure they're both switched. Because on the problem, we have a 5-volt source, so make sure that's going to match. I mean, it won't matter just yet, but might as well do that now so we don't have to worry about it.
And where do I put it into the breadboard?
I just put it at the very top. It doesn't really matter, but just so we're all the same, I put it the top prongs here and put them here at the first hole So the first, what is it? 1, 2, 3, 4, 5. First 5 holes are pretty much covered. And I just put it right there. So the next one would be, I think it's like 6 or 7, right below it. Okay. All right, so let's start measuring the actual resistors, and then we're going to put that into our Excel file. So make sure these are plugged in the correct spots. And we're going to switch the multimeter to 2000. So just turn the switch all the way down to 2000. It's pointing exactly downward, right? And I'm going to place these resistors that we pulled out. So make sure you pull one of each from these bags, little baggies here. I'm going to put them on the breadboard just to measure. So just touch both leads on both sides of the resistor. And you should see a number here that's close to what we think it is, right? So this is the 270 resistor, theoretically, but it's measuring at about 268. So in your Excel file, you will put for the measured value for resistor 270, which is part nut resistor 1, you're going to write 268. Okay. So you're going to go shift to your Excel file. And right here for resistance, you would put 268. That's it. Then we're going to do the next one in just a moment. Are there any questions about that so far? I'm trying to measure it on here just because I don't want, if it touches my hands, it might affect the resistance. Okay, let's do the next guy. All right, let's see what this one is. I already have, I don't know if they're in order anymore, but we'll find out in just a moment what they are. This one looks like I don't think 220 exactly. That's pretty cool. All right, so the 220 measured at 220. Okay, switch that out. Try to measure the next one. Looks like 149. I don't know what yours is measuring at. They will all be different. So I expect your numbers to be similar but not the same. So here is my Excel for all the resistors. Excuse me. I remember we calculated this kind of quickly last time. Is there any issues with measuring the resistance of each resistor before we move on to, before we build the circuit and measure voltage and current?
So we should be measuring two of the 270, or no, one 270, a 220, and 150.
Yeah, you should be measuring those resistors from those packages. Let me get the power source for later. You should have an AC connector for your power source here, the circuit board. It's kind of hard to plug in without unplugging it, but it's fine. This is a power switch here. I'd say leave it off until we're done. The light turns on and it's not off, obviously. Okay, so go ahead and start building the circuit, but I already mixed up my stuff. So let me figure out which one's which while I'm paying attention. The 270, okay. I think they're in order. This is probably 220. Yeah, okay. 270, 220. All right, I should mix it up now. All right then, so what you're gonna do is plug in the 220. It doesn't matter where exactly, but I'm gonna choose right here above the 12 in the positive. Let me zoom in for you. I'll unplug the power, I don't need that yet. So plug it in one of the red, doesn't matter which, but if you want to do the exact same ones as I do, I'm doing it right above that gap right here, which is, looks like number 11 or 12. Okay. So I'm pulling it in right there.
That's 220.
Yeah, I'm doing the 220. And then I'm gonna go across that middle line there over to, let's see here. I'm gonna try to keep it in the same row. So I'm gonna go to row 12, I guess. Okay. So remember, this one is considered to be in series, right? So I'm gonna put it right here, and then we'll talk about what parallel looks like. Trying to make sure that it's in there. So here it is for the first guy. So it doesn't matter which one you pick on this side, just make sure it's in one of these sections. Don't put in ground or negative or positive, right? But once you pick a spot, the rest will go in that same row, okay? So the next one is 220. So 220, I'm gonna put it in that same row, so right here. Oops. Hopefully I don't break this crap. There we go. So I'm putting in that same, appears to be row 12. Now I'm gonna go downward and connect it to a different row. It doesn't matter which. I'm gonna choose like 21, I guess. It's kind of hard to manhandle these things in there. Okay. There we go. So I got, trying to make sure I'm on the right orientation here. So these two are in the same row, but not the same hole. Make sure they're in different holes here. Okay. So these are connected into one circuit so far. We haven't closed the circuit yet, and we still have another resistor. So now we're going to put the 150 in parallel. So the 150, I'm going to put in that same row, row 12-ish, whatever that looks like. Looks like 11 or 12. As long as it's the same one, doesn't matter. Then I'm going to connect it. guy in that same row at the bottom, just to stay organized. So these two right here, we go back to the diagram on the Word document. Bend the crap out of them. Oh well. Make them a little prettier and adjust it. There we go. So these two, well, you can tell, they're in the same row on the top, all three of them, right next to each other. These are going downward, connecting to a new row, and I chose 21. The number doesn't matter down here, but once I choose it, they're all going to be in the same one, because these are in parallel. This is in series, okay? So now let's close the circuit because there's no more, right? Let's look at the diagram. So yeah, we have, this is the first one we put, right? It's connected to the power, so that's why this one was connected to that red spot, the positive. So it's going to here, and it connects to these two, and then these two go downward, and then we got to close it off back to here. Okay, there's no more resistors. So grab this little kit, this guy here. Doesn't matter which one you choose. I chose this white one just because it can maneuver a little bit better. So I'm gonna use this to close this circuit, stick a little jumper cable. Okay. All right. So I left that first hole on row 21 open so I can use that to close it. Okay. Let me show you in just a minute. And I'm going all the way to 21 on the negative to close it off. There you go. So right next to these parallel resistors, right? I left one little hole open to close the circuit. And I'm putting this one on the negative. Okay, so this goes from positive, first resistor, connects to the other two here in that same row. And then they go downward to 21, and then I close it with this jumper cable. Okay? I'll give you guys some time to connect these. Now let's measure voltage in a second when you're ready. Change this, change your multimeter to, change it to 20 amp. Has anyone not finished the circuit, or anyone having problems?
Good.
You good? Okay. All right then. So switch your multimeter, and then we just put the probes or the leads on each side of the resistor. But I guess I should connect the power source first. So connect your AC adapter in the back, and then pray that it's not broken stuff from China. Turn it on, and then put the leads on either side of the Look, we got want to. It's not coming out. Let me try these two here. Okay, resistor voltage should be about 1.24. Let me check everything. Switch clear. Good. Resistors are in there. Oh, sorry. I had it on the wrong 20. 20 here, not 20. My bad. 20 M is for currents. We're doing voltage. All right, so measure it, and it should be about 3.72. Our theoretical voltage that we calculated yesterday, Monday, was 3.76. There's 3.72. Okay. So let's switch to our Excel file. So we'll go here. So the voltage at R1, resistor 1, was 3.72, right? That is at least for mine. You're going to put something different for yours. Okay. Double check. So I already forgot. 3.7. I'll change it to 1. Okay, now I'll go to the next one. Resistor 2, the 220 resistor. That is 1.23. Now, if you get a negative value, that means you're holding it backwards. So just take the positive. It's not a big deal. So if I switch the orientation, right, it's now positive. So yeah, 1.23. So just like we calculated, we're getting a 1.23 because those are on a branch. So they should be equal. Okay. So, and in our notes, I don't think I mentioned it, but the voltage will be equal to volt V1, right? Voltage at R1 be equal to the sum of these two voltages. Let me see if that's right. This one, right? 2, 3. Oh, sorry, that's for current. Sorry, truth. They're equal at the branches. For current, the sums are equal to this guy. Anyway, we'll talk about that in just a moment. You guys have any issues with the measurement of voltage so far? I'm assuming you guys are all getting different numbers too.
Yeah, it's working out for me.
Cool. Okay. All right then. So measuring current is a little bit more annoying, but it's not too bad. Let's see. So this time I'm going to switch this to 20 M. Okay. But our measurement is going to be in milliamps, so we'll have to convert. Okay. So all you have to do to measure this is pull out. So let's do resistor 1 first, right? So what you got to do is pull out the back end here. And put one lead on this guy, and then touch another resistor to get the measurement, the appropriate measurement. So this guy that's sticking out, touch one of that one, touch one on the ground, and then get, I don't know if I can keep my hand steady. 1.343. 13.43, sorry. Double check that because that doesn't sound right. $13.44. Okay. So that's milliamps, million being 1,000, right? 13.44 divided by 8,000 is what I'm going to type in here. Yeah. Yeah. Okay. Now just double checking. Okay.
What are you touching the ground to?
So you touch this back end here, and then you touch any other resistor, and you'll get the voltage, or sorry, the current at the one that's sticking out. And if you have it backwards, just as you see, I just switched it. You're going to get a negative value. Okay, so there's no wrong way to do this. Just make sure that you're touching this end here. Show you. The one that's sticking out, right? That pulled it out. Touch that end, and then hold the other lead to any other resistor. So I can just press this guy. Okay, and then you'll have the current here on the first one. Then you'll just repeat for the other two. Okay. I'm putting that back in. Okay, so now I'm going to pull out the middle one. Pull out the back end here. I should have brought some pliers or something, but whatever. Tweezers. So pulling out the middle one. Okay. Then I'll hold one lead to the part that's sticking out, and then the other lead will just touch a resistor that's not unplugged. That's it. So do it again. And I get negative 5. Negative 5.40 for mine, which is actually, we're going to put the positive. Okay, so 5.40. Let me show you how I'm going to type it in Excel. So since it's in milliamps, you're going to hit equals 5.40 divided by 1,000 because we need it in amps. Because I'm going to have you do it in amps. So it's not too far off from the theoretical that we calculated with the formulas, right? Now do the next one in the same way. So I'm going to plug that back in. And pull out the last one and measure it the same way. So this is going to be the 150 resistor. All right. And I'm going to put this one as my ground or whatever. Here we go. I'm going to say it is 7.95, it looks like. Yeah. Okay. Shift back over. This will be equal to 7.95 divided by 1,000. So that error is a little bit bigger. And I give you formulas in the Word document as to how to calculate percent error. So in here, you'll create a little formula. Okay, and that'll be part of your lab report too. So we have so that's all you have to do is put in the measure for resistance, voltage, and current, and compare that to the theoretical ones that we find with a formula. Okay. Is there any question on this first circuit?
Are we just doing the same for the other two?
Yeah, pretty
Circuits?
much. That's all you can do for the other two, and then you'll just write up a little report and answer the questions. But I do want to show you that the circuit's a little bit different, because it looks like these are in parallel, but they're actually in series with each other because it doesn't branch off over here. So these are in series, but this one is parallel to both of these. So you're gonna have to calculate this formula differently, okay? And these are old semester, we'll get rid of those. Those are not helpful. And here are the theoretical values, which I hope you can calculate yourself for the practice. But if you use these, that's, I mean, I'm not gonna give a crap about it. But I would like you to learn how to use the formulas in Excel, the commands and stuff. Okay, so we're going to figure out this is in series, these two are in series, distance parallel to those two. So let's try to create this circuit. I'm going to use the same ones because we're low on time, so we're not going to actually do the measurements, but I'm going to show you how it's supposed to look. Okay. That way you can at least, you should be able to create both circuits. Okay. Okay, so here we go. So I'm going to remove everything, I suppose, except that first one. And I'm not going to care as to what is what because we're not going to measure anything. So unplug the right end. Let me turn the power off. Okay, so all you have to do, or what I want you to do, is basically do the similar setup, but we're just going to make it a little bit more compact. So what I'm going to do is move the first one into the left-hand side into the first plug. I'm going to use the 12 on the second slot there, right here. Okay. So just like this. And then I'm going to use another resistor, very similar to before, right next to it on 12. And then move it down to 21, I guess, just to keep similar to what we did before. It's just that we're doing it closer to make space for the next couple of resistors here. Okay, so this is R1. I know that they're not the same resistors, but just pretend that we got new ones because we're out of time here. So this one is R1. This is R2. This is parallel. Okay. So the other two, we need to make them in series, but parallel to R2. Okay, so let's grab whatever resistor, straighten them out. They're all kinked out already. I'm playing with these randomly today. Okay. All right. So plug it in right next to it on 12 up here. Okay. All right. Now to make it in series, I'm just gonna plug it just wherever on the close it off. I'm gonna plug it into the third hole on 17, I guess. Doesn't really matter. Just want to make sure I have room to do stuff. Okay. We got all bent. Right, so they're all on row 12, right next to each other. So on the second, third, and fourth, they're connected here. Okay, and then this one goes all the way to 17. So this one is parallel to this guy, but this one is in series, and so is the first one. Okay, they're not connected in the same place. This is connected somewhere random. Okay, so it's in series. Now I'm gonna just grab a fourth resistor, just pick a random one again, just for lack of time here. I'm gonna plug in one end to the 17. So I'm just gonna get another one. So we have 4 resistors here, because on this example they have 1, 2, 3, 4. So right on 17, I'm gonna plug it in to the second hole right there. And I'm gonna close that off to where the parallel one's at. So I'm gonna go all the way to 21 right here. Okay. Alrighty. So one more time. This one right here, resistor 2, is parallel to both R3 and R4. R3 and R4 are in series, and so is R1. Okay, so now we're just going to close the circuit. So grab the white jumper cable and use the 21 and the negative. That's it. There we go. Yeah, that's it. Okay, so now we'll close the circuit. So R1, R2, R3, R4. And I'm using, right, look at the Excel file, right? So there's R1, R2, and then the two parallel R3 and R4 that are in series. So if I had pulled out 47, 220, 330, then I could measure all the voltages and currents just like we did before, and they're all going to be 5 volts. That way, you don't have to worry about it being off. So the goal, let me show you before you go. The goal of the lab is to calculate each voltage and current in the branches, and then compare that. So verify the accuracy by comparing it. Right? So you're going to use this formula right here to create this in Excel. to measure the percent error, which is what I had already plugged in. Okay. I don't think we're using an Elvis board, but you're just gonna follow what we just did. And when you're done, just take a small photo and throw it in here somewhere. It's not a huge deal. So calculating all that stuff for circuits 1, 2, and 3 is about 20 points for each one. And then just write a report with these requirements. Okay. So please read this carefully and before you start. You guys have any questions about this? And of course, I mean, I'll post some videos on just the theory too, just so you can have some background. You guys have no questions then? Does it seem doable? Is it, no, I'll give you some extra time on it. I'll give you about a week or two.
Yeah, I think I got
Sounds
it.
good.
All right, guys. So, well, I'll see you Monday, and maybe I can answer some questions. Once you start doing it, you'll realize you have a bunch of questions, right? So, we can figure stuff out then.